So in this lecture, we will uh, we will learn to solve some numericals regarding the statically indeterminate problems. So let's begin. So suppose suppose we have a road um, which is made up of two segments, um, like this thing. So we have one road and it is made up of two segments. So one is steel, one segment is steel. So consider this segment as steel, and other segment is made up of say this is made up of aluminum. Okay. Okay, and the length of steel section is 150 millimeter. 150 millimeter. Area of the steel section is 300 millimeter square. 300 millimeter square, and the Young's modulus for steel is 210 GPa. Now let's talk about the aluminum part. So length of the aluminum part for this question will be 100 millimeter. Area of this aluminum part will be 400 millimeter square, and Young's modulus for the aluminum will be 70 gigapascal. Okay, so now so this system will be subjected to some load P, like in this manner, and the value of load P is equal to 18 kilonewton. So we have to find the stress induced in steel section and the stress induced in aluminum section. So you can see here that since both the ends are fixed here, so this is fixed and this is also fixed. Since both the ends are fixed, we have to calculate the support reactions first. So the reaction will be like for this force delta P. Okay, so since the force is in this direction, so the reaction will be in this direction. So suppose this reaction will be R2, and to oppose this load P, the reaction will be in this direction, and consider this reaction as R1. Okay, so let's solve. So we have already talked about the methods of approaching for this type of questions. So first we have to find out the equilibrium condition, and then second we have to find out the compatibility equation. So let's find out the equilibrium condition first. So equilibrium condition. So in fx, sigma of fx is equal to 0 for equilibrium condition. So we can say that R1 plus R2 is equal to P, because R1 and R2 in the same direction, so we can write them together, and P is in the opposite direction, so we can write P here, which is equal to 18 kilonewton. So this is our equilibrium equilibrium equation. Now let's focus on the calculation of the compatibility equation. Compatibility equation. So since both the ends are fixed, so we can write delta L in this case equal to 0. So we can tell uh, length of delta L of steel plus delta L of aluminum is equal to 0. So let's break or simplify this equation further. So we can write delta L of steel is equal to PL by AE form. So that is delta L is equal to PL by AE, which we have studied in previous lectures. So let's break it. So we can write P steel, L steel upon A is area of steel multiplied by Young's model of steel plus P of aluminum multiplied by length of aluminum divided by area of aluminum section multiplied by the Young's modulus of aluminum section. Okay. So let's substitute the value of P steel. So we will take plus R1 multiplied by 150 divided by 300 into 200 plus R1 minus P multiplied by 100 divided by 400 into 17. Basically we will take only one term, that is R1 single term. Okay, so after further simplifying it, we are going to get 0.00238 R1 plus R1 minus 18 multiplied by 0.00357. So after further simplifying, we are going to get 0.00595 R1 equal to 18. So we are going to get the value of R1 as R1 is equal to 10.8 kilonewton, and similarly we can find out the value of R2 also. We are going to get the value of R2 as 7.2 kilonewton. Let me clear this thing first. So there are a few things you should keep in mind. So after calculation, if you are getting reaction as positive, reaction value, if you are getting reaction value as positive, then you can think that the magnitude of reaction is okay, magnitude is okay, and the direction of reaction is also fine, that is, it is positive in nature. Okay, now if reaction is negative, if reaction is negative, uh, then the magnitude is fine, no need to modify further. And if in case of direction, we had to reverse the direction in case of we are getting the negative reaction. So let's calculate the value of sigma steel. Sigma steel is equal to load of steel divided by the area of steel. So the value of P steel is 10.8 kilonewton divided by area of steel, that is 300. So we are going to get the value as 36 megapascal, 36 megapascal, which is tensile. Similarly, stress in aluminum component will be P aluminum upon A aluminum, which will be minus 7.2 kilonewton divided by 400, which will be equate to minus 18 megapascal, which is compressive in nature.